to take a look at the one-way ANOVA. The one-way ANOVA is similar to the independent samples t-test. It's another test that's going to compare the means between different groups of people. The difference is the independent sample t-test can only find two groups. So I had to separate people by male and female or by some other grouping that only had two groups. With an ANOVA, I can have as many groups as I want to have in theory. So I could compare 10 groups of students. I could compare students at 10 different ages. And that's a really strong benefit of the ANOVA. With the t-test, though, the advantage to the SPSS analysis is that it differentiates your p-value based on if variances are equal or not. So that's one thing that we can't do in the ANOVA that the t-test does. The reason I tend to say the ANOVA is the stronger analysis, though, is when your variances are not equal, you can do what we call a post hoc test. And in that post hoc test, we really dig deeper and we validate what we're finding despite the variances being equal or not equal. You're going to see more about this in the post hoc test video. So when I want to do the ANOVA, I'm going to do one today with math achievement, visualization, and grades in high school. So we're going to say our research question would be, is there a statistically significant difference on the math achievement test, visualization test, and grades in high school between students whose father's education, and I'm going to go pull it up in this group, whose father's education is high school grad or less, some college, bachelor's or more. So remember that research question, we want to get really robust with those groupings. So now I'm going to go back into my window to run the analysis. I'm going to go to compare means and my ANOVA. I've moved my three tests into my dependent and I've got my grouping variable here. In the ANOVA, you don't have to click the options to define the groups. It does that automatically. That's another benefit of an ANOVA. You want to click options because it will undo this every time you change your screen. And you want to make sure you've checked off descriptive and you've checked off homogeneity of variance. We need both of those information. Then you're going to click OK. And it's going to complete the output for your analysis. And so if I look at my output of my analysis, see where it went. It's always fun to hide the outputs. Here it is. All right, so if I look at the output of my analysis, I get this huge table. And so what this table is the software divided up the values for math achievement and they put students into groups. I have 38 students whose fathers had high school grad or less. I have 16 who had some college, 19 who had a bachelor's or more. For those groups, these are the means. So I already know from the descriptive table that the means are different. What I don't know is, are they statistically significantly different? That's what the ANOVA tells me. And so this descriptives table is for you to come back to once you've identified all of your analysis pieces, and we can be able to do that. So what we're going to look at now is we're going to look at that test of homogeneity of variances. And if I'm looking at that test, I want to look at the sigma value just for the top row. So I'm always looking at the sigma value based on the mean. And so when I'm looking at the sigma value based on the mean, I'm not thinking about my research question about math achievement, visualization, and grades in high school. That's not what this table is for. This table looks at specifically if there's a difference in variance. So for this table, my null hypothesis is that there's no statistically significant difference in the variance between groups for every variable. So I have the sigma value of 0.049. 0.049 is less than 0.05. So I am going to reject the null hypothesis that there's no statistically significant difference in the variances for math achievement. This violates my assumption because I have to assume they're equal. And if I'm rejecting the fact that there's no difference, I'm saying that they're not equal. So it might be helpful for you to say, if you reject the null, that means that the variances are not equal. If I look at visualization though, I have a score of 0.153. That is greater than 0.05, which means I'm going to fail to reject the null. So when I fail to reject, that's the same as saying the variances are equal. And the same thing is true for grades in high school. So only one of these violates my assumption, and that's math achievement. That's going to be important in a little while. Now we're going to look at the actual ANOVA. If I look at math achievement and I look at my p-value, this goes back to that original research question of, is there a statistically significant difference on math achievement test, visualization, grades in high school between students whose fathers have a high school education, some college, or a degree? Because my p-value is less than 0.05, I am going to reject the null that there's no statistically significant difference. Therefore, what am I saying? I'm saying that there's a difference in math achievement score for students whose parents have the different levels of education, or whose father. For visualization, though, I would fail to reject the null. So I actually find out that for visualization tests, there was no difference in the means of those groups that was statistically significant. Again, I can see there's a difference in the means, but the difference is not statistically significant. And then for grades in high school, again, I'm going to reject. So I'm going to say there is a statistically significant difference on grades in high school for students whose father's education, la 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 la. So that's the first half of the test. So you're going to want to mark down on your paper, math achievement violated the variances assumption. That's important. Math achievement had a significant difference in means. Visualization did not have a significant difference, which means I will not do a post hoc test for it. And grades in high school also had a significant difference. And so that is how we will look at this for the first half of the ANOVA test. From there, we will move on and we will take a look at the post hoc test.